I'm going to go over a few problems from the Math 3 Unit 5 Worksheet 4, and we're going to start with number 2. It states that 1,800 students at Cal State University took a biology exam. The scores were distributed normally with a mean of 70 and a standard deviation of 5. Label the mean and 3 standard deviations from the mean. So 70 is our mean, so it goes right in the center here. And then we're going to add 5 to move to the right, so we got 75, 80, 85. So we've gone 3 standard deviations to the right. Then we're going to subtract 5 to move to the left, so 65, 60, and 55. And before we answer any more of these questions, we're going to use the empirical rule, or otherwise known as the 68, 95, 99.7 rule, which states that the middle, well, if you go 1 standard deviation to your left and 1 standard deviation to your right, you cover the middle 68% of your data. And because this distribution is symmetric, we could split that 68 to 34 and 34. '95 says if you go 2 standard deviations to your left and 2 standard deviations to your right, that covers the middle 95% of your data. So if that's true, then, and we've already accounted for 68, so it's 95 minus 68 is 27% left. And again, this is symmetric, so if we cut the 27% in half, we get 13.5 and 13.5%. And we can check that if we add all 4 of these numbers up, 13.5 plus 34 plus 34 plus 13.5, you get your 95%. And then 99.7 spans 3 standard deviations to the left and right of the mean. So that would go from 55 to 85, and that should cover 99.7% of the data. So 99.7, and we've already accounted for 95%, so that leaves us 4.7% left, and split between 2 sides, so cut that in half, and you get 2.35% on each corner. Okay, so now add all those up, you can confirm that that's 99.7. But there is a little bit after the 55, and there's a little bit after or on the left of the 55 and to the right of the 85. Because we've only covered 99.7 when in fact there's 100% of the data to account for. So if I subtract 99.7 from 100, I get 0.03, and then I split that in half, and I get 0.015 for each corner. Once you have this written out, all the questions afterwards are going to be really simple. So, part A. What percentage of scores are between 65 and 75? So we see we got 34 plus 34 because that falls within this region here. Which is 68%. B, what percentage are between 60 and 70? So 60 to 70, that would be 13.5 plus 34. Which comes out to be 47.5%. Next, What percentage of scores are between 60 and 85? So 60 to 85. So you just add up what's there. So you got the 13.5 plus 34 plus 34 plus 13.5 plus 2.35. It's going to be 97.35. Next, what percentage of scores is less than 55? That's just this little piece here, which is 0.015%. What percentage of scores is greater than 80? That's going to be two pieces. We got this right here. So we add together 2.35 and 0.015, which is going to be 2.5%. Next, we're asked approximately how many biology students scored between 60 and 70. Well, if we look at part B, we have 47.5% of the students scored between 60 and 70. And if we look at our problem, there are 1,800 students that took the biology exam. So we need to find 47.5% of 1,800 students. To do that, we're going to change our percent to a decimal, so that's 0.475 times 1,800 which is 855. Part G, approximately how many biology students scored between 55 and 60? If we look at our diagram above, we see that we have 2.35% of students falling within there, and the total number of students is 1,800. So to find that, we're going to multiply 0.0235 times 1,800. Which comes out to be 42.3, but we need to round that to the nearest integer, which is 42, because we're talking about students here. H, if Ron scores 80 on his biology exam, what is his z-score? So a z-score is how many standard deviations away from the mean you are. And we can go back and we see that from the mean of 70 we move to the right 2 standard deviations to get to 80. And if it's to the right, it's a positive z-score. And we've moved 2 standard deviations, so the z-score is 2. If Amos had a z-score of -1 on this exam, what is his biology exam score? So a z-score of -1 means you've moved 1 standard deviation to the left of the mean. So if we look at our diagram, we move left 1 standard deviation from 70, we're at 65, and so that's telling us that he'd get a 65% on his exam. Next, let's take a look at number 10. A sample of restaurants in a Calfine city revealed that the distribution of the price for a cup of coffee was normal. The price for a cup of coffee at Mogo Joe is $3.26 and has a z-value of 2.24. What is the average price for a cup of coffee in the city if the standard deviation was 25 cents? So a z-score, by definition, is your value minus the mean over the standard deviation. Okay, and we're given the z-score. So we know z is 2.24. We're given the standard deviation, 25 cents is our standard deviation. And we're given the value, because that's the price for a cup of coffee, and we're looking for the average price, which we're looking for the mean. So we're going to plug this into this formula, and we get 2.24 is equal to $3.26 minus our mean, we'll put x bar, over 25 cents. So I'm going to change that to dollars, so 0.25. To solve this, I will make a proportion, cross multiply here, and I get 3.26 minus x bar is equal to 0.25 times 2.24. So 2.25 times 2.24 is 0.56. So we get 3.26 minus x bar is 0.56. I'm going to subtract 3.25 from that, and we get negative x bar is negative 2.69. And then multiply both sides by negative, and you get the mean is 2.69. And we're talking about dollars here, so $2.69 is the average price for a cup of coffee in that city. Next, let's take a look at number 15. For the graph of the data set below, what statistic would be a better measure of spread of the data? The standard deviation or the interquartile range? Explain your answer. Well, we have two types of measures. We have non-resistant measures, and we have resistant measures. Okay, non-resistant measures are measures that are affected by outliers or changed by outliers. Or extreme values, and those would be the mean and standard deviation. Resistant measures are those that are barely changed or not changed at all by outliers. And those would be the IQR, the median, and so in this case we're looking at some data that has, you have a bunch of data centered here, but then it spreads, tails off to the right. It's skewed to the right is what we say. So we have a lot of small values off to the right and possibly some outliers. So when your data is like that, we're going to want to choose resistant measures. And so IQR, the interquartile range, is what we're going to want. And that's our answer. Lastly, I'm going to do the challenge question with you. We have Tim, who scored a 95% on his exam and had a corresponding z-score of 1.5. Mary scored a 98% on her exam and had a corresponding z-score of 2. What is the mean and standard deviation for the class exam if the distribution is normal? So I'm going to draw a picture here. Here's our normal distribution. Here's our mean. And if we go 2 standard deviations to the right, we were at Mary's score of 98%. And because it's 2 standard deviations to the right, the z-score is 2. If we go 1.5 standard deviations to the right, we're at a 95. And that has a z-score of 1.5. And we're trying to figure out what the mean and standard deviation are for this distribution. Remember, a z-score is your value minus the mean over the standard deviation. And so I'm going to set up 2 equations. First one, 2 is our z-score, 98 is the value. I'll let x bar represent our mean, and I'll let sigma, lowercase sigma, represent our standard deviation. Actually, it looks too much like a 0, so I'm just going to I'll do x bar and I'll do y. And from this, I can multiply both sides of the equation by y to get 2y is 98 minus x, or x bar. And then I could subtract 98 and get 2y minus 98 is negative x bar. And we can continue and get negative 2y plus 98 is an expression for the mean from that equation. I'm going to do the same thing with the next set of information. A z-score of 1.5 is 95 minus x bar over y. Multiply both sides by y, you get 1.5y is 95 minus x bar. Subtract 95. And multiply by negative 1. Now we have 2 equations, both equal to x bar, so we can set them equal to each other using the transitive property or substitution and get negative 2y plus 98 is equal to negative 1.5y plus 95. I'm going to I'm going to add 2y to both sides and get 98 equals 0.5y plus 95, and subtract 95 from each side to get 3 is equal to 0.5y. If I multiply both sides by 2, I get 6 is equal to 1y. So that's our standard deviation of 6. And now we can use one of these equations up here to find our mean. So negative 2 times 6 plus 98 is our mean. So that's negative 12 plus 98. And that's going to give us 86. And we're talking about test scores, so 86% is the mean, and 6% is the standard deviation.